Money FM 89.3, best of breakfast. Climate Connections.
Welcome to Climate Connections. Did you know that 95% of what we eat comes from a soft, crumbly, and decaying material? Well, yes, we're talking about soil. Besides being used as a productive growing medium for most of our food, soil is also crucial for anchoring roots for plants as they grow, helping to filter and regulate rainwater, which in turn prevents flooding. But this beautiful brown stuff is in danger. According to the Food and Agricultural Organization, or FAO for short, over 33% of soils worldwide are already degraded, and if we let it continue, a shocking 90% will be degraded by 2050. Looking back at his childhood, Rattan Lal, Distinguished University Professor of Soil Science at The Ohio State University, recalls what led him to study soil for the last 5 decades.
Well, in the 60s, when I was growing up on a farm, and part of my family originally came from Pakistan and then came to India. But in the same region, we moved from Pakistan to India about 200 miles or 250 miles, something like this. So it's the same Indus Valley region, and soils are young. They are what we call incepti soil. They are deposited by alluvial material over millennia. But these soils have been used intensively because of very large population. Therefore, the productivity is low. The crop yield before fertilizer came into use in 70s and 80s, but before that in 50s and 60s, when I was growing up, there were no fertilizers yet. So production was low, and therefore food shortages happened very often, and the quality of the food produced was not enough. So in high densely populated countries where soil resources are scarce, I noticed that problem from the very childhood. Therefore, I became interested when I studied in the college to focus on soil science as a subject of my discipline. And I think it's important to mention that at that time, plant breeding, genetics, improving plant variety was a very important topic. So most agricultural scientists were plant breeders, but I realized that plants have to be grown in soil. Therefore, soil health is also important. There is no use having improved a variety if the soil in which that variety is growing is not healthy. And therefore, the importance of soil is very, very critical.
Professor Rattan's work with soil led him across 5 continents, traveling more than 100 countries in a bid to help the world better understand the critical role of soil in the context of the planet's health. It was during this time Professor Rattan saw how soil degradation unfolded right before his very eyes.
I was in Australia in 68, 69. I joined Africa, Nigeria from 1970 to 1987. And while in Africa, I worked for most countries of sub-Saharan Africa, from Senegal to Somalia. And in the 70s, the question of climate change did not exist. There was no issue at that time. The climate change issue came in the 90s, mid-90s. That's when some discussions started coming. But what has happened is that soil degradation became more serious with time, let's say from 70s to at present, over this 50-year period. And there are many reasons for it. Climate change is definitely one, but at the same time, increase in population, tremendous. Right now, we are 8.2 billion. By 2080, we'll be probably 10.8 billion. So the soil resource is becoming a scarce resource. Prime soils of good quality, they are becoming scarce. And just like we say, we have peak minerals, like peak oil or peak gas or peak gold or peak silver. We indeed have a situation of peak soil. The prime soils are no longer available. We require 0.25 hectare per person. In many countries in South Asia, the amount of land available per person may be 0.05 hectare. And that leads to social, political unrest. land grab problem, and then, of course, soil degradation problem. So the soil degradation has become a serious global issue because of population and climate change, and they are interconnected. It's very difficult to separate them. They all are mutually reinforcing.
And just to put soil degradation into figures, there have been estimates that over $40 billion worth of the world's economy is lost every year due to land degradation such as soil erosion. Those are grim stats right there, but what are the causes of this dirty truth?
The soil degradation issues are soil erosion. For example, in the humid climate of West Africa, where I was working, soil erosion by water was very serious. If you go to the northern part, then it coming into Sahara, then soil wind erosion was a problem. Soil salinity is also a problem. In a situation like where I'm working now in the United States, heavy machinery, so soil compaction is a problem. But all these problems of erosion, compaction, nutrient depletion are interconnected with soil organic matter content. Soil organic matter content in a good soil should be about 2.5 to 4%, but many cropland soils in Africa and Asia, part of the Central America and the Caribbean, can be less than 0.5%. So that is the one which sets in motion the problem of soil degradation by erosion, by drought, by salinity, by nutrient mining, by compaction, all those things. The heart of soil health, which leads to eventual degradation. We mentioned population and we mentioned soil scarcity. We talk about food security, and increasing population is going to cause more food insecurity and malnourishment. But one part which I must indicate, we produce 3.2 billion tons of food grains now. Out of that, more than 1 billion tons of food grains reach no stomach, human or animal. They are wasted. So food waste is a very serious problem. So that's one part. We cannot afford to waste 30 to 40% of grains that we produce. We cannot afford to waste 50 to 60% of fresh fruits and vegetables that we produce. So that is one part. If we teach our population use food properly, do not take it for granted, then we do not need to keep producing more. So use properly. But the second part, the average grain production in Africa of cereal is about 1 ton, 1.2 ton, 1.5 ton per hectare, where it should be 4 tons, 5 tons, or even 6 tons. So many regions of the world have low production, low productivity, because the soil health is not maintained properly. So it's not a question of having more land, it's a question of using land we have properly, increasing productivity, using food properly so we don't waste enough of food, and therefore hopefully by 2100, a later part of this century, some land and water should be returned back to nature.
Today, work like Professor Rattan's research on soil carbon sequestration makes up a significant part of the climate change agenda. But what kind of carbon value can we peg to soil?
The heart of soil health, something which is very important factor that determines soil health, is the soil carbon content. And the soil carbon content is 2 types. One is the organic carbon, and organic carbon is the carbon that's derived from the remains of plants and animals, and it's dark color humus. You can buy soil from garden store. It's very dark color, very fluffy. Under natural condition, it gives the dark color to the soil. Soil have more earthworms in it because they consume organic matter, that's their food. So when farmers are poor, like you have seen some of the poor farmers in South Asia, in Africa, elsewhere, they take away everything from land. They take away the grain for their own use, they take away residue for feeding the cattle or building homes, making fences and cooking food. Therefore, soil does not get their share of what it produces. So soil carbon is depleted, and therefore the center I work with, its goal is to improve the soil carbon content through better management, but also make farmers, land managers aware that carbon content in soil is very critical. Therefore, we are promoting a program called carbon farming, growing carbon in soil. Those trees, they fix carbon, but the carbon fixed in land and soil and trees can bring another income for a farmer. And that's what's called carbon farming. And so if we can promote carbon farming, so farmer can get income for growing carbon, they will be motivated to increase carbon content. And this is the payment for ecosystem services. I've been recommending $50 per credit. And one credit is 1 metric ton of CO2, $50. So good farmer on a 1 hectare can probably have 2 credit per year. So they could get $100. And I have been recommending $100 billion budget allocation globally to pay all farmers of the world, 700 million of them, carbon credit at the rate of $50 per credit.
In the early 1990s, Professor Rattan co-authored the first ever documentary report showing how restoring degraded soil through the sequestration of atmospheric carbon dioxide not only improved the soil, but also helped to combat the rising levels of carbon dioxide in the air.
We, in the 90s, realized that the soil carbon was a very critical factor, but it was not a very popular topic. So initially, there were not many people who would be very interested in it. So we arranged a series of conferences. The first conference we organized was in 93, where we wanted to study the potential of U.S. cropland, soil processes, management practices. And then we also started studying these problems in different regions of the world. For example, humid tropics. We conducted a conference in the Amazon region. We wanted to study arid tropics, Sahara. We organized a conference in Tunisia. We wanted to study permafrost soil, frozen soil. So we organized a conference in Alaska. We invited colleagues from Siberia. We wanted to study the mountainous soils of the Himalayan region. So we organized a conference in part of the South Asia in the Himalayan region. We wanted to look at the carbon issues for the arid climate. So we look at the carbon issues in sub-Saharan Africa. So we conducted a regional conference to see whether this problem of soil carbon to restore soil health could be somehow globalized. And yes, there are critical limits of carbon content in soil, and those critical limits vary according to the climate, according to soil type, according to land use, according to the management practices. So I've been very fortunate to work with many colleagues, including soil scientists, including visiting scholars, graduate students, about 425 of them who came to Ohio State to work with us. And when they went back, they did excellent work in their own countries, and they came from as many as 60 countries.
Healthy soil is a dynamic living ecosystem, a complex combination of minerals and organic matter containing air, water, and life. But what components make up good soil, and how does that enhance the function of soil in our wider ecosystem?
First of all, texture of the soil is important, and texture is determined by relative proportion of sand, silt, and clay. So the clay content, if the soil does not have enough clay content, then soils are too sandy. So appropriate amount of clay is very important, and the clay can bind the particle together along with organic matter, and that is called soil structure. So we have a texture, which is particle size, soil structure, which is arrangement of the particle, and the stability of the particle is called structural stability. So that by machinery, by erosion, by wind blowing, by running water, soil cannot be carried away or destroyed. And if you have a heavy machinery, soil may not have too much compaction. And then the amount of water that soil holds, on which all the plants grow, and it's called green water, the plants growing on that. And soil is the largest reservoir of green water. And then more importantly, since 1990s and now early 2000, the new century we started 25 years ago, now we realize that soil is also the largest storehouse of carbon, so that it can moderate climate. So a solution to climate change adaptation mitigation is putting carbon dioxide from the atmosphere into the soil via plant growth.
Thanks to work by researchers like Professor Rattan, we're now aware that soil is not endless and indestructible. So, efforts are currently underway across the world to restore degraded soil. Regenerative agriculture, such as crop rotation and growing complementary crops in the same field, for example, is one method that can maintain soil quality and even restore degraded soil to good health.
One part is what we call integration of crops with trees and livestock. So crops is arable cultivation. When you include trees with crops, then it's agroforestry. When it is also include trees and livestock are silvopastoral system. So when you combine crops, trees and livestock, everything together, it's called agro-silvopastoral system. So the idea is to combine crops with trees and livestock. And that way, the land use system is more environment friendly. But trees cannot be grown very well everywhere. And wherever you remove the trees, and they should not be removed, that is where we have a problem, what we call flood drought syndrome. During the monsoon, flood happened. And during the dry season, because the water did not penetrate into the soil, the drought happened. So flood and drought cycles have been aggravated, they have been increased, they have become more severe if we take the forest away from all sloping lands. So we must define sloping land where the trees should be always kept. And we could take areas which are gentle sloping or flat land where the trees can be removed to grow crops and raise animals. And this is called land use capability assessment. What are the land use characteristics which should be always left under trees, and where the land can be cleared of the trees to grow crops and raise animals, and what are the situations where trees can be combined with crops and animals to make complex system. And this is what the science community should do. They should help farmers identify appropriate land use system.
But as Professor Rattan alludes to, prevention is definitely better than cure.
Restoring degraded soil takes a decadal scale. A restoration of soil takes place on a generational scale, 25, 50, 100 years. So because restoration is a slow and lengthy process, the best thing to do is protect soil. Now, what we have not talked, there are many factors of degradation of soil. We have talked about deforestation, inappropriate land use, plowing, probably removing trees from everywhere. But there is one other factor which is very, very important at present, and it is causing a lot of degradation of soil, pollution of soil, contamination of soil, and that is war. When two countries or two communities fight with one another, and they use heavy machinery like tanks and explosive missiles and many other modern warfare things, they have heavy metal, they contaminate soil, they contaminate water, they contaminate air, and it will take a long time to recover. So we need support from people like you, media, who can promote the idea that the solution to global issue lies beneath our feet.
That was Climate Connections on Money FM 89.3.
To listen to more great interviews, download our podcasts at audio.sg or download the audio app. That's AWEDIO, audio at the App Store and Google Play.